Hi everyone. First of all, I would like to apologize for not being there, and I would like to thank also to ICME committee members for letting us sending a video to attend the conference for this difficult situations for difficult times that we are having in Turkey now. But um, let's me introduce the co-authors of this study. First, Aysun is my student, just a graduate student who graduated, and this is just from her master's thesis. We spent a lot of time with her. And my name is Serkan Ozel, just I'm from Boğaziçi University. And Zeynep Ebrar Ozel is just was helping us on the statistical analysis of this research. The research that we are going to talk about today is on the online review sessions using a webcast system, and it's about the fifth grade students in mathematics classrooms. Before we proceed more, I would like to just start with the research questions, just to give the big picture of the study. The first research question that we were investigating is there significant difference in students' mathematics performance depending on the type of webcast access and webcast use, controlling for differences in the mathematics background. Whenever we say the webcast use, we meant even if they have no access, or access but not use, access with moderate use, and access with extensive use. The second research question, we were investigating the relationship between students' webcast use and their mathematics attitudes. And the third research question, we were investigating how students perceive webcasts for their learning. And as a fourth research question, we were investigating the students' use of webcast system. We would like to define variables in here, and also we would like to mention about their operational definitions. The first variable that we were interested in is mathematics performance. And mathematics performance is defined as the mathematics knowledge and skills based on the curriculum. Here in our study, we just measured the mathematics performance as a total score of 15% of in-class quizzes and 40% of the final test. We had 4 quizzes in total throughout this study. We also just has the another variable to which is access to the webcasts. Which we define access to the webcast as being able to watch mathematics webcasts through online system. That is, students in the study group have access to webcasts created by the research, while students in the control group do not have access to webcasts. We define webcast use as the amount of webcasts watched, and the amount of webcast used are categorized into 3 levels in the study. First, no use, moderate use, and extensive use. Students in the study group who do not watch any webcasts are categorized under no use, and who watch up to 40% in total are categorized as a moderate use, and who watch from 41% to the 100% in total are categorized under extensive use. And we also has mathematics attitude as another variable that we have, and we measured the mathematics attitude using the mathematics attitude scale. Quickly, let's look at the literature review about this research. A webcast is defined as an audio or video broadcast delivered over the web using streaming media technology. That's what a webcast is. And if we look at the educational use of webcasting, first we need to use just the teachers' use of webcast. Teachers use webcast to record of face-to-face lectures, for example, or teachers could use webcast to record tutorials. or delivering short recordings or episodes of important information. And also, the student teachers could use delivering supplementary materials. And also, some teachers use also Webcasts to provide glossaries of key terms. And we can look from the student's perspective how they can utilize the webcast for their educational purposes. Students could use the webcast for gathering missing information. If they could miss a class, and if they have no possibility to use a webcast about their class, they could just gather missing information. Or they could use the webcast to study complex materials, or working through material at their own pace, or listening or watching a lecture that was missed. And another important one is just they can use the webcast for exam revisions. We can just analyze literature for the advantages of webcasting in education. We can just account some advantages as to provide flexibility and autonomy for students, or webcasts allow learners to study while engaging in other tasks. We include the voice of the developer, and also the webcasts are valuable and effective resources for revision of the educational materials. Also, the webcasts motivate, engage just like students, and they're interesting to them. And webcasts could be categorized as beneficial, engaging, and effective in traditional courses as well. Researchers regarding the assumption of the cognitive theory of multimedia learning hypothesized that webcasts should enhance learning. Even though we say that webcasts should enhance learning, and there are some studies that could found no statistical relationships between the webcast access and exam grades. And also there are studies who found positive correlation between webcast access and exam grades. So there are mixed results about the web access and exam grades. Students who use webcasts generally reported these technologies had positive effect on their learning. That's their perspectives. In the review of related literature, no study was found analyzing the relation between mathematics attitude and watching webcasts of mathematics lectures in middle schools. However, there is a positive relationship between technology used in classroom and student attitudes toward lessons. Thus, a positive relationship between technology use and attitude may result in positive relationship between watching webcast lectures and attitudes. In our study, we reached 110 fifth grade students. 58 of them was from the study group, 52 of them was in the control group. We have 2 middle schools within the same school district in Istanbul, Turkey. And one of the school was assigned as an experimental group, and the other school was assigned as a control group. The inclusion criterion was using the interactive whiteboards in mathematics classes whenever we are trying to choose the schools. We had some dropouts from both experimental groups and the control groups, and 5 students from experiment group, 8 students from control group drop out from several reasons, and mostly about the attitude problems in classrooms. We collected some demographic information about our sample because we are using 2 different schools, and we couldn't randomly assign our experimental and control groups to the groups. For that reason, we would need to check their demographic information for their equivalence based on some background information. For that, we use the parents' education levels, and parent education levels are classified according to International Standard Classification of Education. And based on another study, we use the 3 levels of parental education level, and as a low level, medium level, and high level as categorized in the International Standard Classification of Education. Whenever we analyze our groups based on this parental education level, they look very similar to each other if you look at the numbers. And like it's the experimental group, we have 34% of the parents in the low parental education, 42% in the medium, and 24% in high parental education. At the very similar result, like 34%, 44%, and 20% was in the control group too. The average total income for a family in the experimental group is about just like 2,460 9 Turkish liras is about 770 euros, and in the control group is about very similar 2441 Turkish liras. While all experiment groups parents are alive, only one student father is not alive in the control group. And the parents of 4 students in the experimental group and 3 in the control group were divorced. Whenever we look at the computer internet connections at students' homes, the results are pretty similar to each other. The average number of computers is 1.5, 1.4, and just like respectively in experiment and control group. In experimental group, all students has a computer at their homes and internet connection, but there are some students who don't have internet connections and just like the computer at their homes. However, just like we will need the computer used in experimental group, and the control group would not need to use the computer, so it's not going to be a big deal. That's a small difference. We also look just like mathematics background for the students, just like for both groups, and we had just like an independent sample t-test showed no statistical significant difference in mean mathematics background assessment scores between experiment group and control group. So by looking at these demographic information, we just like to show that the 2 schools coming from the same school district has a very similar backgrounds. Even though we couldn't have a randomly assignment groups, we have a very similar groups. We have just as an instrument, we have demographic information survey, mathematics pre-test, in-class quizzes, online quizzes, mathematics post-test, mathematics attitude scale, and reflection questionnaire. Let's quickly describe our Webcast system design. We just like recorded lessons using the internet interactive whiteboards in the classrooms, and we uploaded just like those videos to online video sharing website YouTube. Each lesson recorded was divided into smaller clips according to the subtopics of the lesson. Each video and video clip had an explanation about its content. YouTube videos were shown embedded in the webcast system. YouTube links were deactivated. We didn't want our student to go out from our system, and we want our student to watch the videos within our system because we were recording their watching rates. If they are going to do just like YouTube, we couldn't just like follow their watching. Each student in the experimental group was provided with a username and a password to log into the webcast system. That's like helping us to record students' behaviors in the system. Students' control over the video was restrained to pause and play the webcast and to watch them in full screen. That was the only control that they had within the system. The webcasts were in short video clips format ranging from 2 minutes to the 7-minute long, with exception of video clips. A couple of video clips has a length of minimum just 1 minute and about 14 minutes. This is just some screen captures of our webcast system, and this is just weekly topics is being shown in here. Each week we have subtopics and separated by days. Subtopic in a day is just divided into subtopics within a classroom too. The student have an option to just to watch the whole system in here, or just to watch the individual sections in here too. And the students just could take each quiz that we have only once, and whenever they start a quiz, we are also giving it just um, a message that they could just take the quiz once, but they could review the quiz whenever they want and how many times that they want. And also they were just the time amount that restricted to them to watch, and their grades and their quizzes, whether they take the quiz or not, is shown on their webpage there. This is a sample quiz, online quiz that's just review part of a quiz that students see on these are the videos, and this is just the watch rates, if they have watched, how many part of watch that they see, and this we're saying that one. Two similar schools were chosen. One fifth grade mathematics teacher was selected from each school. The teacher of the experimental group was told how to record the whole lessons, and both teachers were given the same lesson plans, and they both taught the same lesson plans using the interactive whiteboards. This table shows us the similarities and difference between the experimental and the control group. Students were registered to the Webcast system in the experimental group, but no, not in the control group. Demographic information and pretest was applied to both groups, but mathematics attitude skills just applied to only experimental group. The interactive whiteboard lessons were required in only experimental group. In-class quizzes were given for all groups, and reflection questionnaire was given only the experimental group, because the reflection was about just the system. Quickly go over with the research questions that we have. The first research question was to remind that we were looking for the significant difference between the student mathematics performance depending on the type of webcast access and use. To analyze this one, we used a planned comparison analysis of covariance. The second question, we were investigating the relation between the webcast use and their mathematics attitudes. Pearson correlation was used, and the only experimental group students utilized because they were the only one who used the webcast system. And also we investigated the student perceive webcast for their own learning. We just used the reflection questionnaire. And also we just know how students use the webcast system. We use the system log to identify their use of. The data collection procedure took 9 weeks. The collection procedure was twofold: through webcam system and in-class applications. 5 students from the experimental group, 8 students from the control group were dropped out, and we had just 6.35% of the data was missing. Because it was less than 30%, we used a multiple imputation to handle the missing data. Planned comparison analysis of covariance was employed to assess whether student mathematics review webcast access and webcast use level affect their mathematics performance with mathematics background performance as their covariate. Students are categorized under 2 groups according to their webcast access, no access, and access group. Whenever we look at the groups, the no access and no use, moderate use, and extensive use, these are the mean and standard deviation for these groups. These are the planned comparisons of ANCOVA. We compared the no access versus access group, and no access group to the no use versus moderate use and extensive use, moderate use versus extensive use, no use versus moderate use, no use versus extensive use. The covariate mathematics background assessment was significantly related to mathematics performance. We could find a significant effect of mathematics webcast access or use on mathematics performance. Planned comparisons results showed there is a statistically significant difference between no access and access group, while no statistical significance found on other contrasts. These are the values of just like p-values of 30 and COA. Pearson correlation was run to assess the relationship between the webcast use and the mathematics attitudes, and there was a low but positive correlation. And 10% of the about 10% of variance of mathematics attitude was explained by webcast use. Using our codes, like from the reflection questionnaire, we had two overarching themes that were created: perceptions about the system, the purpose to the use of the system. The perceptions, the students just was mostly beneficial. They saw that that's an engaging, and they said it's easy to use. And whenever we analyze the purpose of their use to the system, mostly they use for review, for studying for exams, studying for homeworks, and making up missing lectures. We analyze also looking for the logs and when students watch the videos, and mostly like after mathematics classes on weekdays, and Sundays are the most days that they visit this. And also within a day, like we analyze which part of the day they just use this system. The gray bars showing the weekdays and the blue bars showing the weekends. And even though weekend watches less, but this similar trend we have. And mostly the students watch right after class, and then just in the afternoon. Also, we analyze the whole period of the 9 weeks, and we try to analyze when students mostly watch within this 9 weeks, and we have some peaks in our data, and we analyze what were happening at those peak days. For example, the first peak day, the teachers praise who watch most videos in the classrooms, and right after the praise, the the watch rate peaked up. The second big peak was right before the exam. Another one, we uploaded a game to the system, just and the watch rate increased dramatically. Oral exam, game upload again, exam again. For students who might forget their passwords or ask any questions, a communication form link was available on the main page of the webcast, but students did not use that form at all. Planned comparison and core results show that there was a statistically significant difference between students who have access to mathematics review webcasts and who don't. However, no significant difference in other contrasts were found. The current research was proposing the Webcasting as a review tool. However, the researcher did not know whether students who didn't watch webcasts or watch moderately used any other review mechanism. Moreover, there might be students who didn't review via any medium but understood content. Although the detailed information about the students and their use of Webcasting was traced, no information about reasons for students watching webcasts was traced. When the data were true, some students who had high mathematics performance scores stated on their reflection questionnaire that they found the system very beneficial, but they didn't use the system much because they might be understanding the topic well in class. The result of the current study is important from two perspectives as compared to the previous studies. First, the study not only found statistically significant results, but also practical significance. The results were practically greater than the other studies conducted. Second, this current study is one of the leading studies using webcasts in primary schools, and when considering the effect found and the sample selected, the results are of great importance. This study showed that simple touch in classrooms might have an important effect on student performances. Thus, it is suggested that providing access to webcasts makes a difference on student mathematics. A positive but low correlation was found between mathematics attitude and webcast use. No previous research could be found investigating the relationship between attitude and webcast use. Associatively, there is a positive relationship between technology use in classroom and student attitude toward lessons. From this point of view, a positive and strong relation was expected between webcast use and mathematics use. In the long run, these students can develop more positive attitudes toward mathematics because the system seems generally motivated students. Students generally stated that they found mathematics webcasts beneficial, engaging, and easy to use. Previous research highly supports these findings. They have similar results. Students stated they generally use mathematics webcasts for review, exam preparation, studying homework, making up missing lessons, and these results were parallel to the the use of system, the day of the use of system also similar to the previous research. According to students' reflection, studying homework or review of the morning class after school were the most probable reasons for high webcast watch rates on mathematics class day. Login rates and total webcast watch peaks between 1 p.m. and 2 p.m. The analysis of login and webcast watch time shows that students mostly prefer to watch webcasts right after school and probably after having lunch. That show that it is really important to upload webcasts to the system right after the classes. When webcasts are not uploaded to the system as soon as possible or are uploaded irregularly, students' watch rate might decrease. The day the teacher praised regular webcast watchers, students watch webcasts more than the previous days. Praise was a motivation source for students. Many researchers found that praise increased the children's desire to engage in the related tasks. Students watch more webcasts before exams. Similarly, the other research, Brotherton, Abouts, and Harley et al. And Trapagan's research were showing clear evidence that student use of webcasts and webcasts peaked just before exams. Adding mathematical games to the webcast system affected student webcast watch rate positively. When the games uploaded to the system, students watch more webcasts. The situation shows that students logged into the system for games, but they also watched the webcast before logging out. Students did not use communication link. It might be because their age was about 11 and they're not really used to use those communication links or emails. Providing access to a webcast system as a review tool can be beneficial for students. Webcast systems should upload to the webcast system by teacher immediately right after the class. It is important. Webcasts should be used as a revision or supplementary materials. Shouldn't take place of live lectures because student found interaction with teachers crucial. Students are willing to use webcasts before exams and after lessons, so webcasts can be beneficial for their students. It may be more motivating for students to know that their teachers know they are watching webcasts. Adding attractive materials to the webcast system like mathematical games influence students' total webcast watch time positively. However, these additional materials should not direct students to any website. Students should stay in webcast system as done for the course. There are some limitations in our study and also some our recommendation for further research. The research sample was not chosen randomly, even though we tried to equalize or match both groups, but it's important to randomly assigning to for students to groups to be sure that the groups are equal. During the experiment, the researcher was kept in touch with the experiment and control group teachers, mostly for eliminating teacher effect, although many precautions were taken in order to disable teacher effect. Further research should apply motivating techniques for online assessments. Finally, further research should investigate the reasons behind student webcast watch and not watch reasons. With the help of this data, the effect of the webcast use on achievement can be explained better. Thank you for listening. We are not there and you are listening almost at 30 minutes just like in a video. I hope just like you didn't get bored. Thank you so much for your time and for everyone that gave us a chance to attend this conference via video. You all have a good days and also have beneficial sessions over there.